a constructor. Only you deploy the contract, only then which address is used to deploy the contract, that is the address for the owner account, okay? Owner of this program. Okay? So now, after the end of this is the thing that you saw is very black color, don't worry on that, okay? So you know where is the location and so on. So now, from this one is because in your assignment, you need to draw a use case diagram also. So whether you are using the Durian as Durian for your DF or you're using a leader scan, you are required to have a use case diagram. So you can see that I'm using the use case diagram. From example, just now I got a set as an initial value, then I got increment, I got decrement, I got get function. So all these functions, I will draw it and a use case diagram, and the function actually are in a circle, and who can call this function. Okay? In this case, is anyone can set, can initiate the value. Anyone can increase the value, everyone can decrease, everyone can go and get the function. But logic is initial cannot be called every time. So this is I wanted to show you the use case diagram. So next thing is your assignment also needs you to have draw a diagram which is a contract diagram. Your assignment that mentioned about this one. I do see inside my pen drive. So anyhow, your assignment definitely will asking you a contract diagram. So contract diagram and the class diagram that just now you saw inside your exercise number 3 over there actually are almost the same. The difference is only the modifier. So this is a class name, that is a contract name. Then whatever the data, the state variable, okay, your state variable to store the digital access, the state variable you define at the second row. The third row actually is a modifier, the rule that need to be met when you are calling for your function. So you need to write down your function modifier on the third row here, third space here. So for the class diagram, that is empty, they don't have. So then after that, the below will be the list of the function that involved in your smart contract. Function that may result in the changing the state. Function that may result in the state change and the transaction record on the distributed ledger, you will writing over here. So this diagram wanted to show you a child, whether I'm drawing a class diagram or I'm drawing a contract diagram. How can I draw a contract diagram? Make sure when you go and design your program, you must be design your modifier. Okay, so design your modifier. So define the contract diagram is specify the name, data set, function, rule for the execution of the function access to the data. So this is just a diagram showing you, okay, for your assignment only, okay? So now, next thing, this program, we always under a contract here. Under the contract, you have another subfolder called artifact. You have one subfolder under artifact, and you can see under the contract here, you have a storage.so, owner.so, ballot.so, greater.so, simple storage.so. This is your smart contract, your code. But actually, how your front end call, your front end calling, okay, the front end call your back end is not directly using here. As I said, he refer to your program using the smart contract address. Second thing is your artifact. Where is the artifact? You click on the artifact, that icon. So under your artifact, just now, this is the two things that we are running. Just now we go and deploy. Only we deploy deploy our contract, there will be a simple storage underscore metadata.json file and also the simple storage.json file. This is the two things that we wanted to have a look for today lab exercise number 4. Okay? So now, and then I will going to guide you the differences, how it's looking when you are compile it. Okay? So let me give me a time. The previous program got any like other like other program for front end, back end server got teach you API or artifact this thing? No. Okay. So now okay, so let me go for lab number 4 over here. Okay, so lab number 4 here, we wanted to process, when we process smart contract, compile the artifact, and then we deploy our contract, then we have an API. So this is the thing that for this lab, the purpose is we wanted to know, able to list the compiler artifact, where is the bytecode, where is the API, where is the bytecode, where is the API, function hash, guess estimations. So from this part here, first thing I said, contract, that is a contract address. How this contract address can be generated? We need to use just now your owner address, your owner account. The owner account is one of your EOA account. And the EOA account with the none value are the one who are using to do hashing, then you can generate your smart contract address. So that's why this sentence is telling you the address for the smart contract is generated by using the hashing function, hashing your account number of the contract or your external EOA account with your nonce value, number only use one, that is called NONCE. So a smart contract can be created on behalf of the external own account or apply a program automatically from the command line interface and by script of command for high level application using interface UI. This can be also created by inside the contract. So this sentence, I wanted to tell you that if you have experience to create your own, okay? Just now I mentioned this example telling you that you have the smart contract. This smart contract, you can go and create another smart contract for your own one, okay? Using your high level application. The example is over here, the OpenSea.io. So if you register, when you register an account inside this OpenSea.io, they will create another small smart contract for you, only for you to upload your file, to sell your art or your picture and so on over that site. Okay, so this is the things that theory now. Now, as I said, just now where you get your artifact, why we need to look at the artifact over there. As you can see, when we go and compile our program, they will keep up a two thing. One is your meta.json file, another called JSON file. These two files under your folder called artifact for that. Okay? Now, from this artifact over there, they have these few things inside your artifact. They will tell you that what is the function hash using in your smart contract, and then guess estimation, the web deploy Java script, contract bytecode, and ABI. So ABI is very important because ABI stands for the application binary interface. So it means that it's a detailed function, parameter, and return value. So your front end actually are talk to the ABI to retrieve the data. They are not referring to your back end code in detail one. Okay, they're talking about your front end, how they are contract. And what is the bytecode? Contract bytecode is referred to your back end. Your back end program code which is running by your virtual machine, your Ethereum virtual machine. Bytecode executed for the contract creation. So your bytecode, whatever you saw your .so file, got all your function name, actually they already converted into the low level language which is the bytecode for them to execution for it. So from here, now this is a sentence, just now I draw it out. So Ethereum virtual machine, there is a bytecode, okay? Alright, EVM bytecode is an executable code, it's a code, but for us we cannot read one. It's very complicated, all 01, something like that, very messy numbering, okay, hash value. For us, we cannot read, okay? So that executed, but for the virtual machine, okay, virtual machine, Ethereum virtual machine, they are executed from this bytecode, okay? So then, just now I said, inside your artifact, that is a ABI. This ABI is an interface. This ABI stands for an interface for us to interact with your bytecode. You don't imagine your source file are the one who are interaction. No such thing. We create our source file, we deploy it. It's just we wanted to have a bytecode and the API. Bytecode and API is tucked under your JSON file there. Under your JSON file here. We interact, front end interact your JSON file. Okay, front end interact your JSON file, then from there you can retrieve your API. Okay, later on I will tell you the front end how look like, how to interact for that. So for example, if you wanted to call a function in your smart contract by using your JavaScript code, API play a role of intermediately between the JavaScript code and your bytecode. So you need to have your bytecode for that. Okay? So that's why over here it said that once we are writing the program, you go and look for where is your API. Okay? So API generated from the high level language from this can be used for front end, for blockchain and so on. I don't want to wasting my time just reading this sentence. Now you're looking at your this artifact there. From this artifact, you come down to look at your simple storage.json file. This is the most important file. This is your artifact file that we're referring to. So now from here, okay, you can see from here, when we wanted to call our front end, we are using this file, and then you can see that under the deploy over there, under the deployment of virtual machine, and this is a Midnight, Robston, Recipe, Coven, Gory, Custom. This is how you link from the front end to link it back to your back end. You need to tell me which testnet or which Midnight that you are referring to it. Same thing, we need to go and modify. Now, this is the data for your bytecode. Just now you created your set function, get function owner account then you have this particular increment, decrement function all this is your bytecode, this numbering. Okay, you ask me to read how to interpret, I also do not know how. Okay, already converted so long and so long. So then you learn about open, okay, opcode. Opcode is like an assembly language, okay, can be understand a bit, second lower language. So the op code, operation code over there, stand for operation code, I write on the top there. So this will be the operation code that have to push something now inside your the memory now, okay, core value and so on and so forth. So we don't go and write for that, but you know where is the data, where coming from. These are the one who are run. These are the one who run by the back-end program, by your run by your Ethereum virtual machine. So then we moving on. For the next year, you will see that this one will be deployment for the bytecode. Okay, you will see a lot. Doesn't mean that everything will be involved for you. So now you need to go down to look at your API. Where is your API? Okay, you can see it's very long. Body. This one is another languages. Another language. I'm looking for the API. I know I have a search there, but I don't use. Almost at the end. Almost at the end, if not be mistaken. The U block, YUL block, you don't worry about the things that auto-generate, but it's not for you one. It's not for front-end designer to touch on the U block. As I said, artifact will be generated when you compile your code. The compiler will generate for you. So we go down. Over here, almost at the line number 1601 over there, you are going to see that this will be your gas estimation. Okay, gas estimation, the cost that you need to be code deposit cost, you need to go, and execution cost that you need to pay, total cost that you need to pay. So the creation of your this program that will be charged around this. Okay, they estimate for you how much that you need to prepare for your gas user. So that will be the external. You can see the external here. These are the function. Just now the function that you can create for it. Okay? The function. So that now under your line number 1623, the API. This is what I mentioned, the API over there. So your front end, you base on this API to interact with your back end. So that's why under your function here, first thing, you tell me that you have this particular constructor. So you are defining a constructor, and then you have the address, data type, and so on. It's only for view. Okay? So this will be the something under this part. Later on, when you design for your front end, you are looking at this API, how you wanted to interact with a program. Okay, now, so long. So yes, it's very long because it's by compiler. So this is almost 1693, and the API is almost at the end of your code because you still got other like U language, U block, we are not using it. So now, go and copy this, go and download your code. Everyone, I'm going to tell you what is the purpose that I want you to download your code, because I want you to let you see the artifact generated by the remix and the artifact generated by truffle. Okay, so we're using a truffle compound to generate the artifact. Okay, so now under this, under the .so file here, I go and right click, press download. Okay, so once I downloaded already, so the file is on your download folder there. I copy this, cut it. So now I come back to a folder here. So I put testing under my desktop. Okay, I paste it over here, the source file over here. Alright. So next thing, what I need to do here is I come back to the command prompt. Okay. Oh sorry. PowerShell. PowerShell. PowerShell by administrator. PowerShell by administrator. So now, next thing is I want to change the directive. The directive to come to this over here. I will put it into a CD. Okay. I change to the directive. I don't have time to change on that. So, first thing, when you wanted to, as I said, we already have the truffle version. Truffle version over here. Okay? The truffle version, our PC already have our local blockchain. Okay? So the next thing is, under a truffle or in our entire D app, we cannot just simply compile it. You must make sure your source file put at the right folder. So that's why you need to have a truffle init. So when you have a truffle init, don't worry about that. I'm too fast. Don't worry. I issue this truffle init is I want him to create a default directory for me. I need to have a contract folder, migration folder, test folder, and truffle config over here. Okay? And just now I copy and paste my simple storage.so here. I cut it. I cut this file. I paste it into the contract. I paste it. So under my contract here, I should inside the contract original already got one source file called migration.so. You don't worry about that. That thing I will going to cover later on in your lab number 8 or 9 there, okay? Under that side you will going to learn why we need to have a migration.so, even though I not yet know what is the migration.so, okay? But you already have one there, okay? But anyhow, I just copy my simple storage.so, put it together under the contract, under this contract folder there, okay? So you must be know right file, your file where to put, okay? Now, after done this, we issue a truffle compile. Okay? We want a truffle to compile to code for us. Just now, you're using a remix compile. Am I right? Okay? So once he compile it, they're also telling you what is the source version compiler that he's going to use, and he done it. Okay? And you can see he will, once you issue the truffle compile, immediately he will come to your contract folder. He need to go to the contract folder, look for all the source file inside your contract folder to do compiling. So that's why under this tab over here, under your contract folder here, you were able to see that, okay? Over this contract, nothing to click on. Where is your artifact? Artifact is under a build. This build function has been generated when you compile it. So under the contract here, that is your JSON file, simple storage. This is what I said, simple storage over here. You can see compared to your remix, they give a metadata one. Okay, we don't use metadata. If you open your metadata, this is your metadata. Okay, compiler version, language, API. But yes, under the the metadata, you have the API. But you're not using this API under the metadata to call. I want you to understand. Even though here, your symbol under the remix, you have a symbol storage underscore metadata.json and symbol storage.json. Your backend calling, you'll be calling this JSON file. Not your front end, you're calling the symbol storage.json file, not the metadata. Even though metadata, you also can see API. You say that oh, this one will serve as an interface between your front end and your back end. But actually, this one. That's why under your truffle over here, you saw the truffle. Truffle, when you compile it, he will create your artifact into another new folder called build under a contract also, but it's called symbol storage. Okay, they don't have a symbol storage metadata.json file. These are the most important files. So I open this under a Visual Studio Code. I open by using a Visual Studio Code. Okay, so I change the color. Theme color over there, I change back to the light version. Okay, so that's why you can see this is a simple storage.json file, immediately API coming in already. Okay, so over this side, so truffle will, the front end you're looking for the API for this. Yes, definitely you have the metadata over here. You have this one called bytecode. You have a deployed bytecode. So this is what you saw. Just now I said this will be your Ethereum virtual machine. Then you also will have other like the rest is a U block over there. You are not using by you. It's not run for you. Okay. So all this. So the arrangement of the data is different. You see that? Which how you show me how so long? You say that this one will be used for your program. Where to use? Now, this one is your sample of your code from your lab number 91. Lab number 91. I already unzip it over here. Okay? Lab number 9 already uploaded inside your Google Classroom one. So under called sponsor animal, under this sponsor animal, you're going to see that the build inside contract got the meta, got the artifact over here. So now the JSON file, if you say initial front end, where is your front end? Front end is under source src there. Okay? Under the JSON file here, then I will have an application. Now I open this application. Let you see apps over here is your front end JavaScript. And you can see over this side, open with Visual Studio Code. Okay, now this is how you are linking from your front end. This one now I minus a bit from here. So this one is initial with your Web3, how you connect to your MetaMask. Okay? In using the Web3 provider. This one later on. Okay? So now, when we say that you need to have an account, okay? So this one will be interact with your account. Okay? Get JSON file by using this sponsor animal.json. So you are not contact to the .so file. Okay? You go and get this JSON file. Okay? So you are going to adopt artifact. You go and look for the artifact. Only you can retrieve all the function can be called for this your backend code. Okay? For this part. So this is what I wanted to show you, how is going to link your artifact serve as the interface for you, okay? For you to talk from the front end to your back end. So you are not using the .so file, you are using JSON file from that, okay? So Web3 Ethereum provider, okay? So it's an child. Then you say got the address one. So where is the address one? You say you need to have a smart contract address. Nah? Smart contract address is part under the migration. Under this part. When you come to migrate, which will be under this part. Later on, I will cover for you. Okay? The contract address. Okay? The contract address from this. Under the migration, you need to have the owner address to do migration. Okay? To migrate your program to the back end. So that's why I introduced to you where to look for your contract address. You don't have a contract address, how you do migration? Migrate your program into your back end. Okay? So that's why that is a thing that MSG.Center for that. So I just wanted to introduce for this. Actually, not much. First thing is I introduce for you is API and also the bytecode. Okay, the usings of the bytecode. And also you can see this one KECCAK under your artifact. They can telling you what is your hash function are using. You can see over there. Just now I capture the screen. This is I captured by using greater.json. So then the object. So the bytecode just now already below. Not human variable, but it's read by the machine. This is the thing that I mentioned to you. The object. So the smart contract. So the general here, just now I already compare. I already do this exercise for you. I asking you create a folder. Just now I create a test folder. Then I using the truffle image. Then after that we copy the sample storage inside the folder. So after that we compile. We using truffle compile. From there you understand that where is the artifact will be generated by the truffle. Then you use this artifact generated by the truffle compared to the truffle, compare with the artifact that generated by remix. Then you can do comparison. Then I also telling you the front end how to call this back end, give you the idea why the artifact, the JSON file is so important from the front end as an interface just now mentioned to you. So then this is the thing. Okay? So front end. This is a diagram to summarize today what we learned, okay, for the API. So when you say that you have the front end IDE, okay, your front end, you write your program code, you wanted to refer back to your back end, so you need to go for the Ethereum virtual machine. Your Ethereum virtual machine got API and bytecode. You compile it, you have this, and then you go and deploy it. You will have let's say you put it under the roster network. This is the test network. So then you have all your bytecode data and your bit binary in there. Okay, this is your code. But come to this is why we get the bytecode, where we get the artifact. Okay, artifact compile. You will get the artifact inside your API got the bytecode. But now how to using it? So when you are reading the contract. Reading the contract from the Ethereum, okay? So when you have front end, you have a web tree. So you wanted to retrieve the data from the back end. You are referring to, you need to use the API, okay, to retrieve the data. From using this API, you only can go down for your network to retrieve the data, the bit and byte data back to your front end for display, okay? So this is your compiler. You generate this one, you got your back end for this bytecode. Hope get your idea for that. Hope you get something. So that's why deploy using bytecode. When you deploy your smart contract, you using bytecode under your artifact to deploy it on your testnet from this example. This is your code. We are not directly using your code, just deploy it. You go through a bytecode. Only your bytecode can be executed by your virtual machine, your Ethereum virtual machine. This one is you retrieve a data. You need to use API. The arrow pointing here is how how you're using these two ABI bytecode, these two things inside your artifact. Okay, so not directly from dot, just dot so far. Okay? So that's all for today. That's all for today. Next week we will come to another Solidity language again.